Okay, so continuing on with the slope of a tangent, example 2. So find the slope of the tangent on f of x equals x plus 2 over x at x equals 2. So now we're going to be dealing with a rational function. The process is still going to be the same. We're going to find the slope of the tangent using the difference quotient. It's just the algebra is going to be a little different. So try to follow me here. So let's rewrite the difference quotient corresponding to this specific question. So we'll have f of the a value that we're looking at is 2 plus h minus f of 2 over h. Sorry, I forgot. Here there should be a limit as h goes to 0. So let's do these on the side. As I mentioned before in the previous example, I highly recommend doing these two parts of the difference quotient on the side. It'll just minimize your probability of making an error. So f of 2, let's start with. The function is x plus 2 over x, so I'm going to plug in 2 for the x value. So we'll have 2 plus 2 over 2, which is the same as 4 over 2, which is just equal to 2. Okay, and then let's find f of 2 plus h. So we're plugging in 2 plus h for x into our function, and we'll get 2 plus h plus 2 over 2 plus h. And we could add like terms in the numerator, the 2, so that 2 plus 2 is 4. So we end up with 4 plus h over 2 plus h. So now we're going to take our results here and plug them into the difference quotient that we're working with here. So let's keep it going. So we got the limit as h goes to 0. F of 2 plus h we found is right here. So it's 4 plus h over 2 plus h minus f of 2 is just 2. So let's put a 2 here. Let's actually put it over 1. And that's going to be all over h. And remember what our goal is here. Our goal is to be able to cancel out this h from the denominator. So the way we're going to have to do that in this type of question is to make the numerator into one fraction. So we're going to have to get a common denominator. So the common denominator will be 2 plus h. So the denominator here will be 2 plus h. We multiplied the 1 by 2 plus h, so we got to multiply the 2 by 2 plus h as well. And that's still all over h. Let's put the numerator into one fraction here. So we'll have 4 plus h minus 2 plus h all over the common denominator 2 plus h all over h. And let's continue this question right here. So let's distribute the negative 2 inside the bracket in the numerator. So the limit as h goes to 0 of 4 plus h minus negative 2 times 2 is negative 4, and then negative 2 times positive h is negative 2h over, our denominator stays there, all over h. if you could see here, this 4 and this 4 are like terms, so 4 minus 4, that just nets out to 0. And then we got like terms here. We got this h and this negative 2h. So h, there's like a 1 in front of the h, so 1h minus 2h is negative h over 2 plus h all over h. Sorry, I forgot to put the limit as h goes to 0. So, negative h over 2 plus h divided by h, let's put this h over 1. So what we're doing here, it's like we are dividing two fractions. And what happens when we divide fractions? We have to flip the second one and then we can multiply them. So we'll have negative h over 2 plus h times h over 1. When we flip it, it becomes 1 over h. And then notice how we could cancel out the h's there. So we'll end up with the limit as h goes to 0. The h's cancel out and we replace them with 1's. So negative 1 times 1 is just negative 1. And then 2 plus h times 1 ends up being 2 plus h. And then the limit as h goes to 0, we just plug in 0 for h and we're left with negative 1/2. So our final answer is negative 1/2. So the slope of the tangent of the function x plus 2 over x at x equals 2 is negative 1/2. There's a lot going on here, so let's do a quick recap of what we did. So we were supposed to find the slope of the tangent. So we wrote out the difference quotient, and then we calculated f of 2 plus h and f of 2 on the side here with this function that we were given. So f of 2 was 2, f of 2 plus h was 4 plus h over 2 plus h. Then we plugged that back in here. We for the numerator, we got a common denominator, did some algebra, and it continued all the way down until we got negative 1/2 as our answer for the slope of the tangent.